Hey class, welcome back to Chapter 10, Statistics. Today we'll be looking at Exercise 10D, box plots. Box plots can be used to visually represent the 5-number summary for a dataset. We need to make sure that every box plot is accompanied by or plotted on a clear and even scale. So what that looks like is here in this example. The most important thing here is that this scale is nice and evenly drawn. Each of these little markings between 0, 5, 10, 15, 20 represents the same distance of 1, and each of these numbers is the same distance apart. Okay, it is a clear and even scale. I haven't tried to cram every single number on the lines. Okay, it is quite self-explanatory. I've only included important numbers that help us easily read the box plot. So on that note, we're now going to state the 5-number summary of the box plot and then calculate the interquartile range. So Q0 has been labelled for us, the minimum, at 1. Q1, the median of our lower half of the data, is here at 3. Q2, our median, is at 10. Q3, our median of the upper half of the data is at 16. Probably 16.5 actually, now that I'm looking at it. It's a bit closer to here, okay? And Q4 is at 21. From that, we can now really easily calculate our interquartile range. So the IQR is given by Q3, 16.5, minus Q1, 3, which is, of course, 13.5. So what that tells us is that the middle half of the data, which is represented by this purple box here on the screen, so the middle half of the data, the majority of the data, lies between 16.5 and 3. Okay, so it has a difference of 13.5 points from each other. We're now going to construct our own box plot to represent the following data. Okay, so we start with, from left to right, Q0, which is 1. We're going to place a dot there. Okay, Q1, the median of our lower half of the data, is at 8.5. So I locate 6, 7, 8.5. I'm going to draw a straight line there. Q2, I'm also going to draw a straight line at 13, which is at this notch here. Q3, 15.5, I'm going to draw a marking here. Okay, please use a ruler on yours. And finally, Q4 at 21, again, we're going to just draw a dot there. Now all we need to do is connect the edges. So I draw a straight line from there to there, I draw a straight line from there to there, and then from the middle, I connect those 2 dots, and I connect those 2 dots. Please, please, please use a ruler and the markings in your book. But there you have it, a box plot. You can label them if you like as the numbers that they are. So 1, 8.5, 13, 15.5, and 21 for clarity. They should be along a nice and even scale anyway. It should be all evenly ruled and drawn perfectly, unlike mine on the screen. It should look more like the one up the top here, so that you don't have to label them. You do not ever need to label literally Q0, Q1, Q2, because each of these is consistent with the box plot. So in our box plot, we know that 50% of the data always lies within this range. Up here, it looked like 50% of the data was a lot more of the data than it was, whereas here, it looks like a lot less. It's still the same number of digits, or it's still the same proportion of digits or scores in this box. It just means that we have a much larger range compared to interquartile range. So the majority of the data lies within a smaller range than all of the data, than up in the first example. Okay. And we can calculate that if you would like. The range here is still 21 minus 1, same as at the top. So the range is still 20, but here our interquartile range, just as an optional extra, 15.5 minus 8.5 is 7. Okay, so it's a much narrower interquartile range than in our previous example, even though the range is exactly the same. So we still had a maximum of 21 and a minimum of 1 in both examples. Okay, and that can modify the look of our box plot. That concludes today's lesson, guys. As always, if you have any questions, let me know, but otherwise, good luck with the work, and I'll speak to you all very soon.